What is going on, guys? Welcome back. In this video today we're going to learn how to fine-tune GPT models using Python. So let us get right into it. Alright, so we're going to learn how to fine-tune GPT models using Python in this video today. Now, the process of fine-tuning a large language model basically boils down to providing examples of desirable conversations. So showing the large language model by example what kind of responses we're expecting. So instead of explaining the format and the criteria in a prompt, we provide examples, we provide a collection of conversations that we prepare to show the model this is what good responses look like, and use those as a guideline for your future responses. That's the idea of fine-tuning a model. Instead of just explaining in a prompt or providing multiple examples in a prompt, we have a model that already knows all of these examples because it's trained on these examples. And of course, the more examples you have, the better the performance will be. Now, you can go to OpenAI's fine-tuning guide here on their platform. Then you can see, first of all, everything we're going to do in this video today, but in text form. And you can also see here what the benefits are of fine-tuning a model. You can see higher quality results in prompting. You can see the ability to train more examples that can fit in a prompt. You can see that we save tokens, and we also have faster requests, so lower latency requests. Now, what we're going to do is we're going to fine-tune a model on a simple data set that I created here artificially. I mean, the data set is actually real data, but I just copy-pasted here from my YouTube channel, because what I have prepared for this video today as an example is an Excel file. You can see it here, data XLSX. And this is basically just a prompt. This is what we're going to input to the model, a description of what kind of video I want to make. And then, as a result, what I expect from the model is to get a title, to get a description, and to get tags. So tags for YouTube, basically. And these here are 19 examples. So this is just a headline here. So we have 20 rows, so 19 examples here of my videos on my channel. So we have a prompt explaining what the video is about, then we get a title, a description, and tags. Now, of course, it would be way better to include 100 or 200 examples here, not just 19. And because of that, the results are not going to be perfect or excellent, but you're going to see that the structure is applied, and we're going to see that the fine-tuning does to some degree what it has to do. So what we need to do now in order to fine-tune the model is we need to get this data set into a format that is useful for the fine-tuning process for the OpenAI API. So in the guide, you can scroll down and you can see that the example format here is that you want to have messages, and then you want to have a collection of messages. For example, a system message, then you want to have a user message, and then you want to have the result or the response of the assistant. This is, of course, what the assistant will take as a guideline for future responses or for future messages, because this is the part where the assistant actually has to do something. So this is the format that we need. We need messages, we need system message, and then user message, assistant message. Maybe we want to have even longer conversations. That's also possible. So here you have multi-turn chat examples where you have an assistant, then again a user, then again an assistant. So you don't have to limit yourself to just a simple back and forth conversation that has one iteration. You can do it multiple times as well. So what we're going to do first is we're going to install the OpenAI package. And in my case, I'm also going to install the pandas package, just because I have to read some data from an Excel file. But of course, feel free to use your own example. Feel free to use your own data set. Feel free to fine-tune it the way you want, depending on what you want to do. Of course, it has to be something that maybe the default GPT that is not fine-tuned doesn't already solve quite well. So it has to be something where you have to add some customization into it, where the default model needs a lot of examples to understand what you're trying to do. So come up with something creative, I guess. So what we're going to do is we're going to open up the terminal, and we're going to type pip or pip3 install OpenAI and also pandas in my case. And then we're going to put our data into the format that is necessary for OpenAI. So we're going to start by saying import OpenAI. Let me maybe just zoom in a little bit. Import OpenAI, import pandas as PD. And then I'm going to load the data set here by doing pd read Excel And the file is, what is the file? The file is data xlsx. And then we can look at it. You can see we have a prompt, title, description, tags. Very simple. Just copy paste it from my YouTube. And the goal is now the user provides the prompt and the assistant has a response, or it gives a response where we have a structured title equals this, description equals this, tags equals this, and so on. So we're going to take this and we're going to turn it into the desired format. First of all, however, we need to combine these three columns into a result string because these are now three separate columns. But remember, we have a user prompt and then we have a assistant result or assistant response and not three different pieces of text. So what we're going to do is we're going to say df response strings are going to be equal to applying onto the data frame a function. I'm going to use an anonymous function here, a lambda expression that takes the row, the full row of, so one full row of the data frame. And what we're going to do here is we're going to craft a multi-line f string. So just a string that goes across multiple lines. And here we're going to do the following. We're going to say title, colon, and then row title, like this. Then we're going to use a line break. So I'm going to go down here. Since this is a multi-line string, I don't need to provide a \n. It automatically understands that I'm doing a line break here. Description, colon is going to be row description. And then finally we have tags are going to be row tags. And I think I'm using uppercase here, so I actually have to change this to title with a capital T, description with a capital D, and tags with a capital T. And then we can do it like this. And the important thing now, of course, is that we need to provide the axis. And actually, I'm not sure if it works with the column names. I think probably not, but let's see. Does it? Yeah, okay, it does. You could also go ahead and do row 1, row 2, row 3. This would also work with an index. But now we can get the response strings, and let's get the first one, for example. And you can see that maybe if I print it, we can get a better format. There you go. We get title is this, and actually I have one quotation mark, one additional quotation mark here. So let's do it again. There you go. We have title is this, description is this, and tags are these. This is the format that I have now for all the different rows. And this is what I expect as a response for my given prompt from the LLM. All right, so we have the format, we have the two strings, and now what we need to do is we need to craft conversations. And every conversation is going to start with a system prompt. And the system prompt is going to be a very simple one. It, of course, has to be something that fits your use case. In my case, I'm going to say you are an assistant, one S, of course, assistant that, given a rough video description, comes up with a YouTube title, a YouTube description, and YouTube tags, like this. This is going to be my system prompt. So this is going to be the context that we put at the beginning of each conversation. All right. So all we have to do now is we have to put these three things, so the user prompts, the assistant responses, and the system prompt, into a conversation. So into this format here. So what we're going to do is we're going to do the following. All conversations is going to be an empty list. And then we're going to say for index and row in df iter-row. So we iterate over the rows of the data frame in this case. And we're going to say all conversations dot append. And we're going to append a dictionary here, which is going to have the following format. Messages is going to be a list of dictionaries. And here we're going to say the first thing is role system content system prompt. So you see we have messages, we have a role system content system prompt. Then we want to have, let's do it like this. Then we want to have role user. The user asks a prompt or provides a prompt. So the content of this prompt is gonna be equal to row prompt. And then the response that we want to get from the assistant is actually the response string that we crafted. So we have role assistant, and the content here is, again, I'm forgetting the quotations. So the content here is equal to row and then response string. Was it plural or response strings? Okay, like this. All right, and here we have to close the list. Or did I mess it up now? Let me see. We have a list of dictionary 1, dictionary 2, dictionary 3. Then we close the list, and then we need to also close the dictionary, and then we have our function here. Okay, so this is one conversation. This is one exchange where we have a system prompt, a user prompt, and then the response of the assistant. And we do that now for all the rows. So in the end, we're going to have 19 conversations. So if I say all conversations here, you can see we have a list of these conversation packages. So I can get the first one, and we can see that this is the format that we need for our OpenAI fine-tuning. All right. So how do we actually do the fine-tuning now? What we need to do is we need to put this in a so-called JSON line file. So it's a JSON file where we have the individual dictionaries line by line instead of having one large JSON object and then you have individual sub-key value pairs. You have one full dictionary per line, and then we upload this file to OpenAI, and then we create a fine-tuning job using that file. So the first thing we want to do is we want to create the file. For this, we're going to import JSON, which is a core Python package, and we're going to say with open instances.jsonl. You can call this whatever you want. The important thing is that it's a JSON-L file in writing mode as f. And here now we're going to say for conversation in all conversations, we're going to just say JSON dump the conversation into the file. And then in the end, we want to append a line break. So we can do it like this, and then it should actually, why doesn't it show the file here? Do I need to, there you go, I need to refresh this. Now we have this file with all the conversations here. And this is what we now need to upload to OpenAI. Now this brings us to something important. If you actually want to do all of this, you need to have an OpenAI API key. And I think for the fine-tuning, you have to spend a little bit of money. You can actually see here the pricing table. I think, yeah, $8 per 1 million tokens. We're not going to use anywhere near 1 million tokens here, but it will cost some money. But I think you also get some free credits when you sign up, so I'm not sure about that. The important thing is you need to create an API key. You just have to log in. You have to go to the API, and then you have to go to API keys and create an API key. And then you can just copy paste it. In my case here, I stored it already in a file so that I don't have to show it in the video. I just have to load it from the API key file, and then I can pass it to OpenAI. And I do that the following way. Client equals OpenAI.OpenAI like this. And the API key is equal to open, and then API key read. So I get the file, I read the content, I pass it, and then I have an authenticated client. So what I'm going to do now with this authenticated client is I'm going to upload the file that I just created. I'm going to upload the instances.jsonl file to the OpenAI system, and I'm going to say that the purpose of this file is to be used for fine-tuning. So I'm going to say with open instances JSON-L in reading mode SF. I'm going to say response equals client.files.create. The file that I want to create or that I want to upload is the file F, so the file stream that I opened up. And the purpose of this file is fine-tuning. There you go. So this now, what's the problem here? Oh yeah, we need to do that in read binary mode. So in RB. Another problem, fine-tuning. Okay, sorry, it's not fine-tuning, it's fine-tune. So purpose is not fine-tuning, purpose is fine-tune, like this. And then we can get a response. And this response has an important field, the ID. This ID is what identifies our file. So if we want to use this file, we need to store this ID. So I can copy this here and store it as file ID. There you go. So this is our instances file now on the OpenAI systems. And we need to use this file to do the fine-tuning. And how do we do the fine-tuning? We say response equals client.fine_tuning.jobs.create. And two things need to be passed here. First of all, the file that we want to use for training, for the fine-tuning. So training_file is going to be equal to file ID. And then I also need to specify the model I want to use. And we're just going to use GPT 3.5 turbo. Now, this is going to create a job, and you need to wait for this job to finish. So we can go and say response here. You can see that this is the ID of the fine-tuning job. So I can actually copy this, and I can say job_ID is equal to this. And I think that we should also see here, there you go, finished at none. It's not finished yet. So right now, this is not available. The model is not done training. You can also list the fine-tuning models that are, or the jobs that you're currently doing or that you have done. So client.finetuning jobs list. You can say limit equals 1, for example, to get the latest one. And you can see finished at none. I can also say limit 10. Then I can see also the previous models I trained. And here I think we should see finished at and a timestamp. But we can limit it to 1 to just get the one model that we're currently training. This will take some time. It's not going to be available right away. You will have to wait a couple of minutes. And what you can do then is, or what you can do in general, is you can also say client fine-tuning.jobs retrieve, and you can get the status for a specific job ID. So in this case, actually, it seems like it's done. Yeah. No, it's created, but it's not, no, it's not finished. Okay, sorry, it's created at, but it's not finished at. So when it's finished, you're gonna see finished at and a timestamp. But you can also check it like this. You just get the job ID, you retrieve the status of the job ID. And then what you have to do is you just have to get as a result from this, the model ID. The model ID is gonna be provided, I think, once the training is done. And then you can use that model ID in the playground and also here in your Python code. All right, so the job is now finished, and you can see that this is the case, first of all, because we have a timestamp here now, and second, because we have a fine-tuned model identifier here as well when we retrieve the job ID. So I can just copy this here to use the model later on here in Python. So I can just, actually I can use Control-C. I can say model_ID is equal to that. And then I can decide whether I want to use this here in Python or whether I want to use this in the playground. So I can go to the playground here, I can reload the page, and then I can just select my model here on the right. I have some fine tunes here. Now, of course, you need to know the ID. What was it? It was 9AFGQ. So where is it? 9AFGQ. This is my fine-tuned model. And all I have to do now is I have to mimic the same process. So I have a system message. For this system message, of course, I'm going to copy what I had in here. Okay, seems like I cannot copy, so I have to do it like this in Vim mode, I guess. So I have my, okay, it doesn't work at all. Why doesn't it work at all? Because probably I have to print this system prompt, then I can just copy paste it from here. So there you go, system prompt, and then I can use some description of the video I want to publish. So let's say a video about fine-tuning LLMs with Python. Now I'm not going to use the response of this conversation here probably, but I can now just submit and I will get a response here from my fine-tuned model. It will take some time. As you can see, it's running. There you go. Title, Advanced LLM Fine-Tuning Guide. Description, today we'll learn how to fine-tune large language models, LLMs like GPT-3 using Python. Tags, there you go. This is actually a very good format. I wouldn't call it advanced. This video is quite basic, but you can see that it fits the format of what I uploaded for the fine-tuning process. Now, how do I do the same thing in Python? All I have to do is I have to submit a completion request. So I can say completion is equal to client.chat.completions.create. And what I need to provide here is the model I want to use. In my case, of course, this is going to be the fine-tuned model. So the model ID, actually not as a colon, but as a keyword parameter. So model equals model ID. And then messages is going to be equal to a list of messages, and these messages are going to be dictionaries again. Role, the first one is going to be the system message. So the system message will have the content this, or actually I can just say system message here, system prompt. And the second one will be what I just passed. So it will be role user, and the content is going to be a video about fine-tuning LLMs in Python, like this. And probably I'm not going to get the exact same response here, but this is going to be my completion request. And in order to get the actual result, I have to say print completion dot choices 0 dot message dot content. And as you can see here, I get a pretty decent result. The description is different. I think the title is the same. But yeah, this is how you can fine-tune a large language model or a GPT model in Python. So that's it for today's video. I hope you enjoyed it and hope you learned something. If so, let me know by hitting the like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video, and bye.